Electricity is a circle. So the easiest way I can explain how electricity works is it's a circle. And that's pretty much it. It forms a circle or a circuit, if you will. And I'm going to illustrate this here so you can see. So imagine this is your LED, this is your light, this is your motor, this is something you want to power right here, all right? And then this is your positive, this is your negative. Most things have a polarity. Not always, some things don't. So just be aware of that. Usually if it has wires that are the same color, it doesn't have a polarity, but usually it will be a black wire and a red wire, but not always. That's the best part. It won't, sometimes it's not always red and black. So always read the specs or the manual that comes with it. That's very important. So let's say over here, here's your battery right here. Here's your positive, here's your negative, like that. And you're going to connect your wires to the power like this. There's your red. And then here's your black like this. And that is what's happening there. Power's flowing in a circle like this. This is the basics of electronics right here. The more complicated it is, the more circles there are. Now, obviously, that is a very basic way of looking at it, and that doesn't take into account voltage and amps and watts and ohms and all that stuff. Let's say that this is a 12-volt light. This is a 12-volt power supply. All right, so that's kind of what we're dealing with here. So if you apply power to this, it'll just turn on because electricity is going in a circle. And to break that circle, you would put some sort of switch right here. Let's say this is some sort of toggle switch, right? So there's your little switch there. Now, what this would be here is in this position, the electricity is off. Nothing happens. But if we flip it this way to this position, like that, what will happen is the light will then turn on because it's allowing electricity to flow and complete the circuit. I've got a little setup here. Here is a 12-volt LED. Little tester LED here, and you see that I have connected here. You can see that there's a red stripe to denote positive. Usually red is positive, but as I said, not always. And then over here is our negative or ground, like this. I have got this connected to a plug that's going to go into our power supply. By the way, if you don't know what these are just alligator clip connector jumpers. I highly recommend you get some of these if you don't already have some yourself. One thing I want to mention, and I've actually run into people who didn't know this, I want to talk about this. Electricity is colorblind. It doesn't matter what color wires you use. Red does not looking for a red wire. It's just looking for a wire. However, there are some color codes that have been universally accepted for the most part. Red for this is talking about DC, not AC. AC is a whole separate thing. But for DC power, low power, generally red is your positive, black is your negative. Unless you're dealing with proximity sensors, which for some reason, I think red is brown and blue is negative. I don't know why that became a thing. It just is. Having said that, here's your wires connected. And when I plug this in, the light comes on because there's nothing impeding the electricity from flowing in this circle, as you can see here. So this is our circle going this way, okay? Now, if we want to stop that, we need a switch. Pretty much anything that turns something on or off or impedes the progress of something turning on or off is a switch. It can be a very complicated switch, like an RFID system or a timer relay or something like that. But pretty much anything, all you have to remember is anything that turns something on and off is a switch. That's really all it is. So don't let that confuse you. Sometimes the switch has to be powered by a separate power source. And then this, which is another thing we'll go over, but the simplest switch is something like this. Here's a little switch like this. See this? This is a momentary button. And a momentary button means that until it is pressed, no electricity flows through. So you could also refer to this as a normally open switch. You'll see things that are NO and NC. NO means normally open, which means the circuit is open and no electricity flows through. Then you have NC, which is normally closed, which means the contacts are touching until the switch is changed, and then it opens up. Anyway, so this is a normally open switch. Most reed switches are normally open as well. Not all of them. They actually sell normally closed as well, so make sure you know about that. There are switches like this. These are called arcade buttons. These are the reason for that is they're the kind of buttons you see in arcade machines. All these are, and a lot of these big push buttons, all they have inside of them is a housing for a microswitch. These right here are called microswitches, and I'm sure you've seen these. But pretty much every kind of switch that's a button like this has some sort of microswitch like this here in place. And some of them have these little arms on them like this for leverage, and in this case here these don't, because these just push down. And you've got your toggle switches, which are technically normally open and normally closed as well. This is what's referred to as a single throw, single pole. Single throw means it only goes, it's single throw, it's one direction. You have ones that have multiple positions. This is on or off. This is an on or off. And then this is your poles here. So there's only 2 connectors. Some of them have 6, some of them have 3 or 4. It just depends. So again, something we can get into in a later video. And then here's a weird little switch here. This one's very interesting. This one actually has normally open, normally closed in common as well, depending what you need. But this is kind of a limit switch here. And a limit switch is when something reaches a certain limit, it causes something to do something. And this has a roller on it, so something can roll across it or on it and disconnect it or connect it like this. So all of these are switches, and there's many, many, many other kinds of switches out there. Relays are switches, and I said RFIDs are switches. Pretty much everything's a switch. But we're just going to deal with the very basic switch here, like this. Now, when you wire a switch into something, and I actually did this wrong here. I should have done it on the red side. It is good practice to wire up the switch interrupting the positive, right? So you just imagine that this switch is an extension of the positive rail here, line, like this. So what's going to happen is, instead of these being here like this to cause this to light up, I'm just going to put this here, like this. And the reason you want to put this on the positive is this means that no voltage is flowing through it at all. If you put it on the negative side here, you still have the chance of some electricity flowing kind of in the circuit. If you do it like this, nothing's happening. At least that's what everybody has told me, and that's what I've read, so I'm assuming it's true. And so now, as you can see, the light is not on because the button is not being pressed. But as soon as I press the button, let there be light. There you go, just like that. And when I let go, boom. That is as basic as it gets right there. So just keep this in mind when you're doing something like this. It is just a circle. Don't let it get too daunting. Don't let it throw you. Even if the length is very far, if you've got like a 30-meter run or something like that, it's just a very large circle at that point. So obviously, you're going to need to be mindful of your voltage and your amperage, as I talked about earlier. But for the most part, this is when you're just getting started, when you're trying to understand what's wrong, you're trying to troubleshoot, this is what you need to know. Circles.